Wait,
Okay.
I'm going to from beginning.
Okay.
Who'll start?
Okay. Heat transfer.
Okay.
Convection by Malcolm. Next slide, sir. Okay. Introduction. Convection is one of the major modes of heat transfer and mass transfer in fluids. Fluids that's like gas and liquids. Convection is a transfer of heat by a heated material that moves, carrying heat with it. Yes, transfer of heat. It takes place only in fluids, which is gas or liquids.
Okay.
Why is the guy having a paintbrush there? I have no idea.
The Bay doing that. Next slide.
Yes, please. Okay, there are two types of convection that we learn. One is natural convection, which is a natural convection. The convection currents are set up due to gravity. The cold fluids with higher density will sink to the bottom of a container, let's say container or like in an environment, because its weight is greater than the buoyant force. Hence, natural convection does not occur in weightless environments. In a forced convection, the movement of the fluids is caused by the external forces, such as when there is a fan or a pump. Forced convection increases the rate of heat transfer.
Next.
Yes.
You want to explain or next?
Next.
I want to explain, but I don't know how to explain. There are examples of natural convections include hurricane, ocean currents, sea breeze, and magma movements. That's a lot. Okay. In a hurricane, hurricanes form in two bands around the Earth, usually between 10 degrees and 20 degrees to the north or south of the equator. In these areas, seawater is warmed by the sun so that it reaches the critical temperature of 26 degrees Celsius. A convection current of warm, moist air rises above this water. As it rises, it cools and water vapor condenses as rain, releasing energy. Just as it takes energy, known as latent heat, to evaporate the water, this energy must be released when the vapor recondenses. Okay. Second, ocean currents. Convection occurs because the oceanic waters heat up, becoming less dense. This water moves above the cooler water and gives off its heat to the surrounding environment. As it cools, it begins to sink, and the process begins again. Convection results in the continual circulation of ocean water on a global scale. There are many factors that determine the strength of a current, as well as the route it will follow. Winds have the most important influence on the flow of currents, but tides, precipitation, evaporation rates, shape of the ocean floor, and inflow from rivers and adjacent seas are also important. Okay. In sea breezes occur during hot summer days because of the unequal heating rates of land and water. During the day, the land surface heats up faster than the water surface. The sea has a greater heat capacity than land, so the surface of the sea warms up more slowly than the lands. As the temperature of the surface of the land rises, the land heats the air above it by convection. The warming air expands and becomes less dense, decreasing the pressure over the land near the coast. So that's why I got the wind blowing you.
If a land breeze?
If it's land breeze, then other way around also.
If the land breeze?
The other way around. The water,
Wind.
the sea will have a lower pressure because of the high heat capacity, and the land will have a the land will have a high pressure because it cools down faster compared to the sea.
Mm. So the wind
Okay,
coming from the land to the sea.
sea.
To the ocean.
Mm.
Okay, magma movement. Magma is the molten rock below the crust in the mantle. Tremendous heat and pressure within the earth causes the hot magma to flow in convection currents. These currents cause the movement of the tectonic plates that make up the Earth's crust. When water gets hot, it rises, and when it cools, it sinks. This makes the magma rise, just like the boiling water. When it reaches the top, the magma cools from the crust. It sinks back down to the core. Just like the water, the magma creates movement of a circular motion called convection currents. Bear, you want to do this?
Bay,
Mm,
camera.
okay. The one.
Oi, you have to.
You have to.
Yeah,
Why, sir?
you have to. When you present,
Bear,
you
tôi
have to
lâu
put your
vậy rồi.
camera.
I don't want. I'm not a girl, sir.
I'm not good.
What
Don't
what
seem
are you
to.
talking about?
When you present, you have to put your
I'll
face.
go to your place and slap you, no.
Okay, next one is example of force convection. So there is two convection in air and convection in liquid. In convection in air, if the volume increase, then the density will decrease. So if the temperature of a given mass of air increase, the volume must increase by the same factor. So in convection in liquid, convection can also lead to circulation in a liquid, as in the heating of a pot of water over a flame. Heating water expands and becomes more buoyant. Cooler, more denser water near the surface descends and pattern of circulation can be formed. True, they will not be as regular as suggested in the drawing. Okay, next. So next is occurrence of natural convection and forced convection. In natural convection, when a body cools in still air, still cooling occurs. This is a phenomenon of natural convections, such as when we leave a glass of warm water outside in the wind. Next one is forced convection. When a body cools in a drones, example a fan blowing, it is a forced convection. Next. Okay, convection cells. A convection cells, also known as a Banner cells, is a characteristic fluid flow pattern in many convection systems. A rising body of fluid typically loses heat because it encounters a cooler surface. In liquid, this occurs because it exchanges heat with colder liquid through direct exchange. In the example of the Earth's atmosphere, this occurs because it radiates heat. Because of this heat loss, the fluid becomes denser than the fluid underneath it, which is still rising. Since it cannot descend through the rising fluid, it moves to one side. At some distance, its downward force overcomes the rising force beneath it, and the fluid begins to descend. As it descends, it warms again and the cycle repeats itself. Next. So about cooking. A convection oven is an oven that has fans to circulate air around food. Using the convection mechanism to cook food faster than a conventional oven. Convection ovens distribute heat evenly around the food, removing the blanket of coolant air that surround food when it is first placed in an oven and allowing food to cook more evenly in less time and at a lower temperature than in a conventional oven. A convection oven has a fan with a heating element around it. A small fan circulates the air in the cooling chamber. Next. So this is the Newton's law of cooling. Newton's law of cooling states that in a drag, the rate of heat loss is proportional to the temperature axis, which is the difference between the body and surrounding temperature. Rate of heat loss proportional to the temperature axis. Okay. Tom, I continue.
Who's the third person?
Not sure.
Where's
Malcolm.
Joshan?
Where's Malcolm?
I want to know also.
Okay lah, play lah.
It's okay. I can.
Okay, you can. Minus mark for Malcolm.
Huh?
Is it Malcolm?
So
Sure.
Marks, sir.
Huh?
I
For
mean,
what,
he
the
he's
marks
the one
or
who
what?
did like the
PowerPoint.
he's the one who do the PowerPoint lah, sir.
Oh, okay.
Yeah.
So now it's
Yeah,
between
yeah.
you and Bay.
Ah,
Okay.
yeah.
So,
Sure. I continue.
okay, Tony.
Two examples of natural convection and forced convection. One natural convection, just like we said, occur in the ocean currents such as a Gulf Stream and also the winds going across the globe. The forced convection include movement of refrigerator coolant in the refrigerator and the circulation of a radial fluid in automobile machines.
So the next
Yeah.
question on step hiking trails, there are upward movement of air in the morning and downward movement of air in the evening. Explain this phenomenon. So in the morning, the ground is heated more rapidly by the sun compared to the air. The hotter ground heats the air over it. The air becomes less dense and begin to rise along the hill slope, setting up a convection current. The warm air cannot rise vertically upward as the cool air above is pressing down. In the evening, the ground loose is hit by radiation and becomes cooler than the air. The layer of air above the ground is cooled down and become more dense. As a result, the cool air descends along the high hill slope in a downward convection current. I think that's all. Okay. Thank you.
Sir,
Yeah.
do we learn Newton law of cooling?
No. That's not in our
I
syllabus.
don't know.
They just put it as a
Extra.
what you call general
What?
knowledge for you.
So what syllabus is that, sir?
Maybe a fluid dynamics. There's a one big field in physics we call as fluid dynamics. It's about fluid. Oh, this is by
Fix
Malcolm.
that, sir.
So this is by Malcolm. You see his name? Okay.
Malcolm, he forget his friend's name already, sir.
Yeah, should put his friend's name right. Okay.
Friend's name, that's why he put comma.
Hmm.
Dot.
Go.
One more thing I want to see one unique thing about convection. This is what I say the natural convection. Okay, the natural convection does not occur in weightless environment. There was an experiment when you put a match, like you light a match. Let's say this is match, and then when you light a match, the fire will be, I mean the flame will be like this, like correct or not? the flame of the match. When you have a match and then you lit the match, the flame of the match will be looking like this, right? Correct not?
Yes.
Yeah, correct not? If you have a match, and then you fire up the match, the flame of the match will be showing like this, right? Correct not? This one will be a
Yes.
blue, and this side will be a orange, right?
Yes.
So this is when
Yes,
you have a
yes.
wake.
What you wait?
This is when you have a wake. But when you go to outer space, there was somebody make a like a match. What happened is this one will be the match stick, and then the fire will be like this. So this will be blue,
I see.
and this will be this will be
Is it?
a spear. It will be a spear shape. It's because it's a wakeless environment.
I see.
So how they match it in space?
In the of course in the space shuttle, where we
Yeah,
have a
please.
where we have
Good
a
question.
when we have a oxygen, right? But when it tries, they try inside a space shuttle. Of course, it's actually very dangerous, right? But when I think I have the video in the when they put a mesh, they light a mesh on the wakeless environment, they saw a shape of a spear shape of the lightning of the flame. Okay, I think I will show you. I will put it on the WhatsApp. You check by yourself. The the flame will
Sure, sir.
be a sphere shape. Okay, because actually by conduction, actually the heat goes up like this and then bounce back like that. This is when we have a wake. Okay, examples of natural convection occurs: hurricane, ocean currents, sea breeze, and magma. Hurricane, ocean currents. Okay, and sea breeze. This sea breeze has been asked before in STPM. What is what happen when you have a what actually happen when you have a sea breeze, and what actually happen when you have a land breeze? Sea breeze, sea wind coming to the land. Land breeze, the land wind coming to the sea. So there are two types: sea breeze, sea to the land, and land to the sea. But in I think in the bahasa Malaysia, when you have a uh, what call bayu laut and bayu darat, it actually is opposite. It will be opposite. So you just stick with the English, sea breeze and land breeze. Magma movement and example of force convection, convection in air and convection in liquid. This one is very important. Let's say we have a room. This is a room, and this is the further wall, furthest wall from this. Let's say this is a window, and this one will be the door, right? So let's say we have a room over here, and usually, logically and usually, where do you put a air conditioner? Where do you put your air conditioner?
There's a
In a closed place.
In the
like exactly like that
let's
room
say I put A
Actually,
over here, B over here, C over here, or D. Which one you pick?
on the floor, sir.
Air
D, sir.
conditioner.
I
C or D, sir. Both also
I
can.
choose C, sir.
Choose C. Anyone?
I choose D, sir.
Choose D. Anyone else? Why not A or
A,
B?
B, C.
Hey, choose.
Why not A or
No,
B?
sir.
In
People
A,
put
B.
aircon on top.
Floor,
I
sir.
found there's a reason.
Why not A or B? Why?
Our house all on top only,
I
sir.
don't want. I don't want.
Because the cold air only like falls down, right? To the gravity. So
Cold
you
air
put on the
goes.
bottom.
You put
So
on
the bottom
bottom.
also no use, since it's only go down.
Cool air drops and replaces the warmer air.
Yeah.
So,
Really like
So?
this one.
so what Tony said, you should be put at A and B. Is it what you said?
No, sir.
No, I say it shouldn't be put at A and B.
It
Yeah,
shouldn't be pure
shouldn't,
A.
because so the cold air will remain down there.
Okay.
Correct.
Ken,
So,
is your screen blank again?
So that means your room has ghosts.
No? I think
okay.
this time.
So the answer is
You're very
actually you
quiet
have to put
for
at
once.
C or D. You see, if you have put a air conditioner here, okay, I put air conditioner. What happen is, okay, so the cool
Actually, I
air
tried.
goes down, right? The cool air goes down, and when the cool air, of course, when the cool air uh, warm up because of the room temperature, it goes up, right? Warm up, it goes up, correct not? The goes down, the cool air goes down, and then uh when it increase the temperature, heat up, it goes up, and then goes up again like this. So this one will be the cool air, this one will be the hotter air. Hotter air must be at the upper side of the room. So that's why you put air conditioner on the C or D. Why not?
Correct.
So the
Correct, sir.
cool air goes down as it heated up, it goes like this. So this one will be the answer. So
Yeah.
you
Oh,
never
you're right there.
see a heater, right? We don't have a heater in Malaysia, but in the same room, let's say it's the same room like this. Where do you put a heater?
A and B, sir.
You put a heater at
Below.
A and
At
B.
the back.
You put a heater over
B.
here, right?
Yes.
Because
Yes, sir.
by the
Like we
convection,
see in America.
it goes up, the hot air goes up, and then when it goes down like this. So this is hot air and the cool air. So nobody put a heater at the upper part of the room. That's the reason. Okay. So the convection of air. This is what happened. Convection of air and convection in liquid.
So we put C or D. So,
Either C or D is the correct answer. Okay. A and B is the wrong answer. For air conditioner. Okay, not for heater. But there was actually one viral thing in the internet. If you put a fan, if you put a fan in the middle, where is it? If you put a fan in the middle of this thing, okay, it will be interrupting the cooler, the hotter air coming back to the aircon. So if I put a fan over here, right, this purple color is a fan, ceiling fan. It will interrupt the hotter air going back to the air conditioner. Okay, so actually it
Not
was not
good,
designed
sir.
to have the air conditioner was not designed to have a fan, ceiling fan at the middle of the room. Okay, unless the fan is moved to other side of the room a little bit far.
Teacher, where you get the information and share the link later.
Hmm?
Can you share the link about that information?
I forgot. Okay. It's a
I never
viral
heard it
thing.
before.
Okay,
But
what do you think, Ken?
So how
shouldn't
we
that,
interrupt?
It will
shouldn't
be
that
you will be interrupting or
shouldn't that
not?
we put
The wind will
shouldn't that
be
we put the fan is increasing the ventilation of air?
no, the cooler air should be going in the cycle, going back, going the upper side of the room, but the fan is pushing to the bottom, so it will be like this. The cooler air will be keep going in the bottom of the room. It's not going up against up. Of course, the fan is pushing down, right? It's not pushing the air up. Unless it's pushing air up, it will be different story.
Unless they want the air to be pushed down, sir.
Yeah, that's the thing, right?
It is there, right, sir? Then he want
Unless the fan is sucking air, goes up to the upper side of the room, there will be different story, right? But the fan is actually pushing the colder air going downwards. Right? It doesn't have a cycle jadi inside the room.
So it's more cold.
It's not. It doesn't. Actually, the cycle of the room is not continuous. Understood? Right? Actually, there's no air going to start in put there's no cycle, and then
Sir, what I see before is shouldn't that we open the fan is increase the air ventilation and the room is get cooler more quicker.
You mean the air must more separated,
The fan
must
help in the convection of air.
have the convection of air. They will be mixed. I think actually they will mix around here. They will mix of air hot and cool, right? Hot and cool. But the cycle, I mean the cycle of the air coming from the air conditioner, it doesn't goes back into the air conditioner. Understood? Like it should be one cycle goes up back like this. Air conditioner push out a cool air, and then it goes up like this, goes back inside, sucked back by the air conditioner. But it was prevent by the fan. It prevent. So the fan pushes back, so it be like this. Understand that? It doesn't go back into the air conditioner. Okay. And next, can we go next? Oh, we have something here. Set. Okay. Okay, forced convection cell, cooking, and this is actually just for your entertainment. It doesn't have anything. Okay. Ocean currents such as Gulf Stream, winds blowing across the globe, forced convection, coolant in the refrigerator. Forced convection always involve a fan. Okay. Circular of radiator fluid in the automobile engine. Okay, upward movement in the air morning and downward movement in the air evening. Explain the phenomenon. Okay. So that's it. Okay, actually there are no calculation in convection.
Sir, but I checked from Google,
Hmm?
mostly they say open a fan with together with the air condition in a room is help in the air ventilation and it's both and it increase the cooling effect.
At this side, right? At this side, at the lower side of the, I mean, below the fan, correct or
Not
not?
lower side.
The
Lower
whole
side
thing.
also can.
So how
Yeah.
does how does the air coming out? It goes back to the cycle goes back to the air conditioner. Unless actually, you mean okay? Let's say this fan we move to other side, little bit far. Answer not. Little bit far from the air conditioner. This one I think there will be some of the air can goes back to the air conditioner. But if the fan is near to the air conditioner and the room is very small, I think you cannot have a one cycle goes back into the air conditioner. The fan itself will be preventing the cycles of the wind or the air coming back to the air conditioner. Unless you have a very big room. If you have very big room, let's say you have a very big room like this, okay, where the air conditioner is one side and you have a long hall, a very big hall, and you put your fan over here, you have a air conditioner. Of course, the fan will be helping you to mix the cool air over this side, and some can be goes back over this side. Correct or not?
Two air cons, sir.
You put two aircons.
No,
One at here. Sir, I don't know how to draw. How to use the
Which
pen.
one?
the fan just changed the direction actually.
Change the direction.
Can I share my screen?
How?
I don't know how to draw.
Okay, you put it on the WhatsApp later. Okay, we discuss about this. Okay,
Okay.
this is under fluid dynamics. It's hard to explain. People do have a simulator, gas simulator. When you have a computer, you have a gas simulator, you can show what's happening. Lots of factor actually. Hmm. Unless you have a fan like this, right? This fan is a standing fan, and then push up back.
Another.
A standing fan. You put a standing fan. One more idea. Maybe it is a standing fan. This is a standing fan. You put like this, so the cool goes down, and then he helps to put up the fan back. Yeah, this one should be a good idea. Standing fan rather than a ceiling fan. Of course, the fan will be the one who mixing up the hot and the cool, right? The one who separate. I mean, it will be helping the mixing of the convection, the air inside the room. But it depends on the position of the fan. Oh, kid Ken is drawing, I think, in the on the paper. Okay,
I'm not.
and
I'm not drawing one.
okay. Any question anymore?
No, no.
No. Okay. So we stop
Sir,
here. Yeah.
uh, can I? Can you send me the link for about? Can you send me the slide for the first group present?
Okay. Okay. Can.
Thanks.
Okay. So next group will be Ken.
My group.
Black body radiation. Okay.
White body.
Is it tomorrow or Friday?
Yeah.
Today is
No,
Friday.
tomorrow.
Today.
Tomorrow no physics.
Tomorrow in physics or
Monday.
next week. Okay. Okay.
Next week, sir.
Next
Sir,
week. Okay.
sir.
Yeah.
Just I make some declaration for the first topic, conduction, thermal conduction.
Okay. Ken. If you want to help the first group also can. Okay. Less than 1 minute. We have to stop. Zoom is telling us to stop. 40 minutes, right?
Okay.
Okay. See you tomorrow. Next week. Bye bye.
All right, sir.